Alright guys, in the last video we talked about how we can take the inverse of an exponential function, and that inverse is going to be considered a log function. Alright, so the inverse of an exponential is going to be a log function. Alright, so just to recap, if you had something such as this, y equals 6x, and we wanted to go ahead now and take the inverse of this exponential, we could replace the y with x and the x with y. So now we have x equals 6y, okay? And this would be considered the inverse. Now, rather leave it in this form, we can write this as a log function, okay? So we don't want to leave it in this form. We don't want to leave it as x equals 6 to the y power, okay? We want to write this as a log function. So using our rules up here, or two equations, we can go ahead and write this as a log function. So we know that we're in this format right here, x equals base, and then our power of y, okay? Well, we can now translate this into a log function, so this will simply become log base 6, okay? Then we have x equal to y, all right? And just to confirm here, if you were to graph this guy right here and graph this guy right here, they are going to be exactly the same. These two are exactly the same. All right, that's very important to understand. All right, simply just being written in a different format. Okay, so again, these two are exactly the same. Very important concept to understand. Okay, so let's go on to evaluating log functions now. Okay, now that we have kind of a basic rundown. Well, before I get into this, I just want to clarify one thing. If we had a log function such as this, so we have y equals log of 5. All right. Notice here that I'm missing a base. If I'm looking right here, I have my log. I don't have my base. I have my x value, right, my y value. There's no base though. If you do not see a base on a log, you assume that there is a 10 there, okay? You assume there is a 10, a base of 10. Okay, that's just an unwritten rule. If they don't give you the base, there must be a base of 10. Again, so for example, if I had y equals log 7, again, there's no base here, so we assume that there is a base of 10, okay? If I have something like this, y equals log, base 3 of 7. Well, in this case, I do have a base, all right? So I do not assume there is a base of 10, all right? I only assume there's a base of 10 if it's not written, okay? Okay, let's get on to a problem now. All right, so let's try our first problem here. Let's do, we're going to have here log, we'll do base 3, 81. Okay, so what I want you to do is use these equations that we determined that we're going to use for log functions. Okay, here it is as an exponential, and here it is in its logarithmic form. Okay, well, I have log base 3 of 81. Okay, what I want you to do here, because you'll see problems like this, set this equal to y. Okay, and now this becomes a lot easier to evaluate. So how are we going to evaluate this log function? What do you think we can do here? All right, well, we know that this, in its exponential form, is the same as this in its logarithmic form. So we can go in between, or we can go back and forth between log form and exponential form. So here I have it in its log form. How could we write this in its exponential form? All right, so how could we do that? Well, simply just following the rules here, right? Here is my base, 3, and it's telling me I'm going to raise 3 to the y equal to whatever x is, in this case is 81. So I'm going to have 3y equal to 81. This is exactly the same as this, all right? And now all you want to do now is solve for y. And we want to use mental math here. what could I put in for y that will give me 81 here? So 3 to what power will give me 81? Right, 3 to what power will give me 81 here? Alright, so when you do this, you're going to determine that it's going to be 4, right? 3 to the 4th power is going to be 81. So let's go ahead and write that answer. We're going to put y equals 4. Alright, or you could just put 4 here. Alright, that is going to be your answer. When you evaluate this logarithmic function, alright, the answer is going to be 4. So log base 3 of 81 is 4. Okay, let's try another problem. So I'm going to erase this. We have log 1000. Okay, first thing, set this equal to y. Okay, also notice we're missing a base here. So based on what I said before, if we're missing a base, we need to put in a base of 10. Alright, so if it's not written, you put it in. Alright, now again, we want to evaluate this log function, so we're going to put it in its exponential form. When we do that, we will get 10y equal to 1000. Alright, and now you're just simply saying to yourself, okay, what am I going to plug in for y here that will give me 1000? So 10 to what power is going to give me 1000? Again, try to use mental math here. Well, you're going to come up with an answer of 3. So your answer here is 3. So log base 10 of 1000 is 3. Alright, let's try a couple more here. Let's do log base 4 of 64. Again, first step, when you're evaluating these, set it equal to y. Okay, and then put it into its exponential form. So here we go. Now we're saying to ourselves, 4 to what power is going to give me 64? Right, and that's going to be 3. So again, we get 3 here. Alright, so log base 4 of 64, the answer here is going to be 3. Let's try one more, a little more challenging. We can have here log base 4 of 1/4. Okay, first step, as always, set it equal to y. And then let's go ahead and put this into its exponential form. So when we do that, we get 4y equal to 1/4. And so this one is a little bit tricky. You really have to know, all right, your properties of exponents here. So 4 to what power will give me 1/4? So 4 to what power will give me 1/4? And good job if you got this, it's going to be -1. Remember here, 4 to the -1 power is the same as 1/4, right? It can be written that way. So you really have to know your properties of exponents here. So our answer here, based on this, right, is going to be -1. Okay, our answer here is -1. Alright, so that is how you go about evaluating log functions. Alright, and that is it.